Hello everyone, this is Hippo. Today we will talk about 2A2, mass spectrometry and relative mass of atoms. First, the relative atomic masses and the relative isotopic masses. I have told it before. So first, we will learn spectrometry. First, we have to learn the MZ ratio. Is the mass of the ion divided by the Z charge of the ion. It's important. Okay, second, we have to learn how does mass spectrometry work. You say the spectrometry is used to distinguish the isotopes of an element. So first, the sample must be vaporized, and it will go into a ionization chamber. It's to let it become an ion. And the electron gun is to accelerate it. And also, the electric field is also to accelerate. Now, this is the magnetic field. Magnetic field is important here. We have learned in this class, we know that as the mass of the proton, mass of the substance increase, its deflation is decreased. Like this. These two, electron and proton. So we can know that this is higher mass point, this is lower mass point, this is the medium mass point. So only this one, the medium mass point, could go into the ion detector and be detected. There are 4 simple steps you have to remember. First, vaporization. The sample needs to vaporization. Second is the ionization. Is the vaporized atom clad with the electron to form ion. And second, acceleration is the electric field, and fourth is the deflation. It's used to determine the MZ ratio. As the MZ ratio increase, the deflation is decreased, like this one. Why the MZ ratio will increase? Because the charge of the ion also the same in the same electron, but the mass of the isotope are different. So if you have a higher mass isotope, you may have a less deflation, but if you have a smaller mass isotope, you will have a bigger deflation. Go to this point. Okay, now we are going to the diagram, the mass spectrum diagram. This is a relative abundancy, or the relatively, like this one, intensity. These 2 diagrams are same. This is abundance, the different isotope in an element, and this is a ratio. We can give you an example, like this one. This is a sample of the bromine vapor. We know that the bromo have an isotope, 59 isotope or 61 and 60. These 2 are different bromo ion. No, this is wrong. The bromo have 3 different isotopes, 79, 80, and 81. Now we can learn this is the single bromo ion, and they are molecules. They are combined with 158 combined with 2 bromo with 79 atomic mass, and the 160 combined of 1 of 79 and 81, and 162 combined to 81. Okay, here are 2 definitions you have to learn. It's a relative isotopic mass and relative atomic mass. I told you before. The molecular ion peak, the peak with the highest MZ ratio in the mass spectrum. Peak, the relative abundancy, is this, the highest relative abundancy, 100. So if the question asking you, you have to write 2, 1:2 and ratio 1. You can write down this one, 100% ratio 50%. This is wrong. The only thing you can write is this. And also in the exam, you must remember this. All the atom or isotope you write here is ion. You must add ion or the positive or negative charge. You will lose 1 point.